Welcome back to the Building HVAC Science podcast. It's our goal to help create better, more knowledgeable HVAC and building performance technicians by helping these two professions better understand each other, work together, and make customers happy in the homes they live in and the buildings they work in. Building science crosses over with HVAC to a large degree. Today's episode, Eric and I get a chance to speak with Matt Schwoegler, who's the founder of Blaze Infrared and a longtime thermography educator and friend of mine for quite a while. Matt will share his unexpected journey into the world of infrared, from a marketing career in the ski industry to teaching thousands about heat transfer and thermal imaging. Now, with deep humility and clarity, he walks us through the critical lessons from his 20-plus year career, including some humorous and humbling stories from the field. Biggest point here, Matt tells us how interpreting thermal images isn't as straightforward as it seems. Goes over some nice examples from that and explains that and drives that point home very well. And our conversation closes with a compelling call to approach thermography with humility, curiosity, and a commitment to continuous learning. Matt pays tribute to his mentors who shaped his path and encourages listeners to seek guidance, invest in training, and pay it forward. Some quotes from Matt. The price of the camera has nothing to do with your ability to use it well. Humility is the most important quality of a great trainer. And infrared is like a hammer. It's easy to pick up, but only a skilled builder knows what to do with it. We've also got a ton of references in the show notes to some of the topics, the standards that Matt mentions. And of course, links to Blaze Infrared, the infrared training center who Matt contracts with, and Matt's LinkedIn profile. I also threw in a link to TrueTech Tools Thermography Basics video from our library. It's been out for about 12 years, but the physics really hasn't changed. Okay, let's get on to this episode with Matt Schwoegler from Blaze Infrared and cover the topic of Beyond the Image, Lessons in Humility and Heat Transfer with Matt Schwoegler.
Good morning, everyone. Welcome back to the Building HVAC Science podcast. Eric Kaiser right here and Mr. Bill Spohn right over there. The legend, the man, the myth, the whole 9 yards, all rolled into one. He loves it when I do that.
I don't.
And we've got a great special guest with us today. Hopefully this will be a very enlightening conversation. Oh, yeah. Mr. Matt Schwoegler from Blaze Infrared is going to be talking to us about heat transfer and thermal images and all those fun things. So welcome to the show, Matt.
Well, great. Thank you for having me, Eric. Thank you, Bill. It's great to see you.
Yeah, same here. Boy, I've known you for a number of years, like going way back to the original weatherization programs, what was that called? The ARRA?
The ARA fund. I was trying to think of the word there before, but it was the ARA funding, and that was late 2000s, and I was at Snell Infrared, and yeah, it was about then. It's hard to believe. What is that? 15 years plus now?
Yeah, 16 years, yeah.
Yeah, unbelievable.
At Snell, that's where I met you. You had the role of doing training across a, no pun intended, but broad spectrum of infrared applications.
That's right. Yeah. So I was doing a lot of work with buildings at the time that we met. So it was weatherization. That was the big push with the ARA funding. But I got started at Snell back in, 2002, I think. It just happened. It's one of those things like you always ask yourself, how did I end up here?
Mm-hmm. Right place, right time.
Yeah, exactly. And I had started off in the ski industry of all places. My background's actually in marketing. I went to school for marketing. And wanted to go into the ski industry for a long time. It was my dream to work at a ski resort, do snow reporting and all of that. And I just realized quickly that probably wasn't the career that it was going to be the path that I wanted for my life. And so I came across an opening for a marketing coordinator position at Snell Infrared. This company you might have heard of, Snell Infrared, Montpelier, Vermont. And I met with Jim Fritz, Rob Spring, and John Snell, and they brought me in and they showed me a thermal imager. And I had never seen one of these before in person. You see it on TV and the movies. And I think, Bill, it was an Indigo system. Do you remember Indigo?
Yeah.
It was an Indigo. For the time, we would think of it as a pretty crude setup today, just where the technology's gone, but that's what it was. And it was state of the art and it was amazing. And Jim showed me the imager and he put his hand on the wall. He does the hand demo that we show in our classes. You put your handprint on the wall and he pulls his hand away and the handprint stays there. And I was hooked. It changed my life. That moment changed my life. And I saw this. I'm like, this is cool. I want to do this. And it was this marketing position. However, I didn't get the offer for the marketing coordinator position. I actually lost it to another wonderful woman who we've become good friends since then. But it was only like 30 minutes after my interview, I get a phone call. They called me back and said, hey, can you meet us for lunch? We have something else we'd like to discuss that we think you'd be the perfect fit for. And that's when they pitched me training. It's like, how would you like to be an infrared trainer, a thermography trainer? I'm like, well, what is that? And that's where it all started. I think it was just my interest in public speaking and presenting that really I was very comfortable with. And I think they noticed that. And they hired me as a trainer. It was in the fall of 2002. And the rest is history. But it took me a couple of years to get up and running. They were incredible mentors, Jim Fritz, Rob Spring, and John Snell, of course. And I get out there and just start teaching classes or at least shadowing instructors, getting on the job training, getting out in the field, learning the curriculum. It would do a number of site tours at countless facilities just to get up to speed on the technology and how it worked. And that's what got me into training, was just an interview that went sideways in a good way. I've been doing it ever since. And like I said, we met probably, 2008. And that's when I was really in the thick of it with weatherization program. There was a lot of funding from the ARA push there, and ended up doing most of the training for a lot of the state weatherization agencies. It was in New York, Vermont, New Hampshire, Mass, Minnesota, Texas, I think Wisconsin as well. And it was just getting that experience, getting out in the field, meeting students, meeting professionals that are active here, learning as you go. It was what really shaped me into the trainer that I am today. And again, it was the mentoring along the way that really made that difference, was meeting these different individuals, including Jim, Rob, and John, but then also students who I would teach and learn things from and other experts out in the industry. And so I did that until about 2013. And then in 2013, John Keene, the director of the Infrared Training Center, reached out to see if I'd be interested in joining them down at FLIR Systems in Nashua, New Hampshire. So I made the move there. It was actually perfect timing because my wife and I were actually thinking of moving back to the Boston area at that time. And so I picked right up doing, again, more training, curriculum development. Throughout all of this, John Keene was also a great mentor, always supportive, really provided me the freedom to work on these various projects. And it was from that we started to do more with marketing and technical content production, because that's when it was really starting to make a name for itself. People were starting to do videos online. And so we built a production studio where we do webinars, technical videos, and other training content. But then in 2021, a once-in-a-lifetime opportunity came up for me, and I pivoted over to Boston Dynamics, where I got to do and run spot operator training for a couple of years. And it was an opportunity I just couldn't pass up. I was really excited about it. I'd been a fan of Boston Dynamics for a while and taught customers there how to utilize Spot and work with the robot, creating inspection missions, analyzing data. I actually produced the first autonomous thermal inspections course for Spot operators. I put that curriculum together. And that was how to utilize the thermal camera. The thermal payload is what they call it, on top of the robot. So people that are using this in industry to look for hotspots, obviously, and really challenging, very exciting, very engaging, really experience for me. But then as life happens, and I lost my dad, and that for me really put time into perspective. And this is about 2022. I'd never experienced that before in my life. And so things suddenly felt very finite. And I started to ask myself, what would I really want to do? Like, what would be my ideal job at this stage in my career? I love working with infrared. I've got a background in marketing. I really enjoy the creative process. I feel like I have an aptitude for video and educational content production, and these aspirations of like, can I do something on my own with this? And that's what really led to Blaze Infrared and going out on my own. And just again, it seems like it happens over the course of my life. At the same time, I reached back out to John Keene at the Infrared Training Center, and they actually were looking for somebody to fill exactly that role. And so I now work and manage their creative production, helping them produce marketing and technical content, producing reels, shorts, other marketing videos, other training videos. I'm working on several tutorials right now. We actually just wrapped one up on an acoustic imager, the FLIR's SI series. And it allows me to have my foot in one area there. And then I also have Blaze, where I have another client where I analyze thermal inspection reports of commercial buildings for them. But I'm ongoing looking to develop an inspection business out of this and do IR consulting, kind of a mix of things. It's really the best of both worlds. And that's what I like the most about all of this, is the ability to dabble in these areas and working in marketing, working in infrared. It's really a dream come true. That's what brought me here today.
Very interesting. Having so much experience in that field, we talked before we started recording here, and you talked about humbling stories and interpreting the IR image. So craft something out of that.
It's a technology that will humble you very quickly if you don't understand the physics of heat transfer, really what you're seeing. When we talk about training, I have this analogy that I've always used in my training classes. Take your hammer, like a typical hammer, like a claw hammer that you use to frame a building. Really easy for anybody to use. It doesn't require a lot of training. You can pound nails into a board with minimal training. A 5-year-old can do that. But it takes a skilled carpenter to know how to frame a wall properly. And that's the same with an infrared camera. It's like the cameras are easy to use. I can give somebody a camera in a training class and they'll very quickly pick it up and learn how to focus and save an image and recall it. But to interpret the data, what you're seeing on the screen there, that is something that really requires proper training and also experience. And the experience is something that you can only get over time. And I think back to some of my early days of training. I've got a great story. It's not buildings related, but it was at a class at an on-site. We were at a hospital outside of Philadelphia, and we were on a field assignment. We were out walking through the facility. I knew enough to be running the class, obviously, but I was still a little green in some ways, as we all are when we're starting off in a certain field. And I remember looking at some bus duct, which carries bus bar. The bus duct wraps the bus bar, and the bus bar obviously is energized and carries electrical power through the facility. And these bus ducts can have heaters at the joints where the bus bars are connected. And the purpose of the heater is to keep moisture out of there, keep it dry. Well, I didn't know that. And so we're going through and we're looking at this. And I'd already taught some of the electrical application material in the course. And one of the things we covered is if you ever see a small temperature differential on these joints, well, that's a really serious problem because of the thermal disconnect. Because the fact that you're not looking directly at the hotspot, but it's inside behind a metal cover, it dissipates the signature. So it looks a lot cooler than it really is. These things could be hundreds and hundreds of degrees hotter. But again, me being a little green, it's like I saw this little hotspot here. I said, hey, took the class. Guys, check this out. Check this out. I think we found a really critical hotspot. We probably just saved the hospital a ton of money or whatever. And I got really excited about it. And then they got into it. They saw the hotspot. Then they saw another one. And then they saw another one. And they said, all these joints had this elevated temperature. And at a certain point, when a pattern starts becoming repetitive like that, it's a flag. Maybe it's not abnormal. Maybe this is a normal pattern. And a guy comes over, he taps him on the shoulder. He goes, there are heaters in there. And the color just drained from my face. I mean, I just felt like a fool because here I fully committed to it. I'm young. I was in my mid-20s and you didn't know. And now I learned. But what it taught me again, go back to mentoring again, is just, and this was drilled into me by the gentleman at Snell Infrared, Jim, Rob, and John, is just always be humble as a trainer. Humility is one of the most important qualities of a great trainer. It's like, know your limitations and know that it's okay to not know something and be comfortable with that. And that's tough. That's tough to kind of admit, especially when you're a so-called, let's say, expert in a certain area, let's say. It's like, I don't know everything, and that's all right. It really helps you grow as a trainer, as a person, as a professional. And that was again, a great lesson, but also a great experience of humility hitting you right in the face at probably the most opportune time. So
I think that speaks to not only have to know how to run the camera, but then you have to know how the equipment you're looking at is supposed to operate. And looking at it through that camera is a completely different method than what we do in HVAC or in building performance or something like that. It's a whole different way of looking at it. So we're probably going to see maybe some oddities in there that we don't understand at first.
Exactly. And things that you will then start to question your reality. A buildings related one that I can share. I was on a roof in Montpelier, actually. It was the building that our offices were in at Snell Infrared at the time. And it had aluminum metal siding with a thin layer of paint on it. And what we talk about in infrared training is shiny metals obviously have a low emissivity, high reflectivity. It's hard to get good images off of these surfaces. You can't get accurate temperature measurements because of the reflectivity and the low E value of the surface, blah, blah, blah. But if you paint it, right? If you paint something, then you increase its emissivity and then everything's fine. There was no problem. That's, again, something that's been burned into my brain. Well, I go at this, we're looking for these high, looking for moisture intrusion on this roof. And I turn and look to the building and I'm looking at what it looks like a thermal mirror, as if I'm looking at a piece of shiny metal, but it's painted, red painted siding on this building. And it looks like the paint isn't even there because I'm getting this, almost perfect reflection of my body heat and everything around me off the side of this painted building. And here I'm thinking, well, I was told paint is a good emitter. You can get good, accurate results off of it. Why is it not working? Why is this happening? And I don't know if I ever really got an answer to that, but it was one of the situations that, again, even with that, you still have to always question. It taught me to always question the image, always question what it is you're looking at, because things aren't always what they appear to be.
So that was like a thermally open paint then. Something like I learned recently that like a Tyvek or building wrap is somewhat thermally open.
You can have, I don't know if it was the material, the paint itself, it was a thin layer, made it a little more transmissive. Some paints can have particulates, like metallic particulates in it. That's a possibility too. It's just one of those moments where you just start to question, but you also, again, grow at the same time because now you have this experience that you can pull from and teach people with.
So how many ghosts have you found with a thermal imager?
So far, zero finds on those, but it is interesting to watch those ghost shows where they show what I think are a lot of thermal reflections or maybe other things that I think can be explained, but doesn't mean I don't believe in ghosts, but I don't know if infrared is finding them. Let's just say that.
Yeah, so the glass is a thermal mirror, can be a thermal mirror.
It can, and that's a big thing too. People don't realize that glass can be, it's not that glass has a very low emissivity, it's that we say glass is very specular. What we mean by specular is your bathroom mirror is a specular reflector. It's like it's a perfect reflection of reality. You can have surfaces that are polished. Yeah. If you polish something up, it can act more reflective than it really is essentially what's going on versus something that's more diffuse. Yeah.
So if you have something like, let's just say, a frosted glass, is that not as reflective then to thermal?
Probably not. Yeah. It's from my experience, it's likely less. Yeah.
Interesting.
And that's the thing with emissivity. You change the surface condition. It's not just the material. It's changing the surface condition can have a tremendous impact on the emissivity of an object.
Yeah. So it's all about the surface. It's not so much about what's in that material or what's behind it.
In terms of emissivity, that's correct. Yep. That's right. It's what's happening at the surface because that's where the electromagnetic energy originates from, where it radiates out. Beneath the surface can still affect the amount of radiation, but that's about conduction or convection or its capacitance. It's other things.
So bringing it back to some common materials that people that listen to this podcast would encounter, there's building materials, there's walls, there's windows, there's copper, there's aluminum, painted steel. Give us a rundown about maybe the cautions or the interpretations necessary.
It's a great question, Bill. It's everything. I make the point that I think building applications is probably the most challenging application for thermal imaging. There might be some debate there, but when we talk about electrical, it's really, is it hot or not? Is it a connection problem or an overload? In mechanical systems, thermal imaging is typically not the first tool to go to. When you're looking at, let's say, a motor, you might look at it with vibration or ultrasound or maybe motor circuit testing. Infrared typically catches patterns, problems a little bit further along in the failure curve. But with building systems, like you just alluded to, you've got all these different types of materials that are in play that affect the thermal conductivity of energy, that affect the thermal capacitance, everything here. I think the best example I can kind of relate to this is I lived in a brick Victorian, like a true brick Victorian in Montpelier, Vermont for several years with my wife, that the first day or two of a heat wave, we were loving life. Like, who needs an air conditioner? This is like, it's 90 degrees outside and we're in here. It's like a potato cellar. It's nice and cool. Our neighbors who live next door are friends in this wood frame building. They got the ACs going right away because they're hot immediately. Well, day 2 hits and that thermal energy finally gets through that thermal mass of capacitance of brick and it turns into a pizza oven. And then the key here is that cold front will come through. Our neighbors are loving life because they got the windows open. Everything's nice and cool. The building's cooled off. We're still sweating it out for another day or so as that brick slowly gives up that thermal energy. And that right there is the essence of a building thermographer. You have 2 different buildings built with different materials that if you were tasked to go inspect this, you'd get 2 very different results. And it'd be very challenging to do. And all of these things, that's why we say in the standards for doing a building inspection for solar loading, a wood frame building, you have to let it settle. I think it's 3 hours where the surface has to be devoid of sun for a minimum of 3 hours before you can image it. For brick buildings, it's 8 hours. You can't have any sun on that surface for up to 8 hours before you can look at it and at least have a prayer of seeing something. But yeah, the building materials have a significant impact on that.
So these standards, what standard making body do they come from and what do they typically address? And do any get into things that we might run into in HVAC or buildings?
ASTM C1060 is the one that I just referenced there. And that one really addresses inspecting structures with thermal imaging to look for things like missing insulation. The other one's slipping my mind right now, but there's ones for air leakage. There is ones for blower door testing, and I can follow up and get you guys some of that. But there are these guidelines that you're going to want to follow with air leakage. You can get away with minimum 5-degree difference Celsius for, I think, checking for air leakage related issues. I think the solar loading part for me is the one that I've encountered probably the most over my career, where it happened here in my house. This is the big one that I always reference in training, where the effects of the sun not only affect the outside surface, it shows up on the inside. And so we had a situation, this was years ago, I'd set up a camera on a tripod and I looked at a wall and I did a time lapse, captured a picture every 15 minutes throughout the day. And it was a south facing wall. And I started at 8 a.m. and it was colder outside, warmer on the inside. And first thing in the morning, what we saw was warm cavities and cold studs. And that's what you want to see in heat loss conditions. You want to see warm cavities, cold studs, because heat is going from inside to outside, right? Conducting through the wall, going from hot to cold. That pattern tells you the wall's insulated. Well, as that camera was capturing data throughout the day, we saw something very interesting happen around 2 o'clock in the afternoon, where the thermal pattern disappeared on the wall. The studs and the cavities suddenly became the same temperature. And then by 4 or 5 o'clock, it switched. The cavities were now colder and the studs were warmer, which, if you didn't think about it, communicates that the wall is actually uninsulated because it's still colder outside. It never got much above 40 or 45 degrees that day. Well, what had happened was the direct sunshine on the wall heated the exterior wall to 120 Fahrenheit. It doesn't matter how cold it is outside. If that wall surface temperature is 120, guess which way heat's going? It's going to be coming inward. And that reverses the pattern. But imagine you're a thermographer who shows up first thing in the morning and they're going to see one thing, and the person in the afternoon is going to see a completely different story unfolding in front of them. And they're going to say two completely different things. That's really sums up for me the nature of building inspections, how challenging it can be. But again, it's a lot of fun. It works very effectively, but it's just you have to understand the physics, the science.
I've got a question in that same vein there. Like when you're taking that test, and this is more from a camera operations perspective, because one of the challenging things that I've found operating cameras is auto scaling. So are you auto scaling in a case like that to be able to see that change, or are you actually just setting your scale on the camera?
So in that particular situation, there's software too that we can use. I had access to where I can lock the scale and then you can see that it keeps the perspective the same throughout the day. So you can see that proceeds more evenly. But you're absolutely right, Eric. You hit on some great points about auto scaling versus manual adjustment. That is another thing. Again, you learn from training how critical it is to understand how to make those adjustments on your camera, because when you're outside, you have things like the atmosphere. Talk about humbling experiences, Bill. I've missed missing insulation in buildings before because I had my camera on auto adjust. And the moment you catch even a pixel of that atmosphere, it's going to drop your scale. Your span's going to go to minus 40 and it's going to throw out and wash out your contrast. You're going to lose that detail on the side of the facade. Same thing inside. You could catch a baseboard heater. You could catch, it could be a hot lamp that's on, let's say with an incandescent light bulb in it. I've seen hot water pipes, steam pipes in older homes will obviously affect that contrast as well. That's why training, again, is important, because you learn to make those adjustments, because you're absolutely right, Eric. It's the auto scaling sometimes can hide these problems on you and you might walk right by them.
Yeah, I've seen that in a couple instances and had to learn that the hard way a little bit on just looking at things, because that's where when I started doing thermography, I didn't have a lot of training. And I can see now that going back, I've had to learn a lot on my own that I probably would have picked up had I just taken a basic training class.
That's important. I think that training is really the best place for everybody to start. I do a lot of classes with the Infrared Training Center. And one of the first things we do in level 1 on day 1 is we get you on your camera right away. And so you learn the basics of operation. How do you save an image, recall it, make those adjustments? How do you manually adjust the scale? We discuss resolution's a big one. A reel that I produced for the Infrared Training Center here recently discusses the importance of understanding resolution. Do you have enough detail to capture areas of air leakage or missing insulation at a certain distance? Inside's not as much of an issue for most cameras, but if you get outside and you're backing up to get big perspective on the wall, for some systems with lower resolution, you get to a point where it's difficult, if not impossible, to see these areas of detail because you don't have sufficient resolution with the camera.
Yeah. And I want to just give a shout out real quick to Infrared Training Center, because one of the things that I did after I started learning just enough to know that I didn't know enough, I hit the bottom of that curve going, wait a minute here, I got to learn a little something more. They've got a great online course called Thermography Basics. It does cost a little bit, but it's a self-paced online course, and I picked up a ton through that.
That can be a great place to start. What you're alluding to is something that I have to give credit to the gentlemen at Snell Infrared, Jim Fritz, Rob Spring, and John Snell from back in the day. It was the levels of competence that they've taught me about being unconsciously incompetent, consciously incompetent, and then becoming unconsciously competent. That's the process that you go through. When you first start out and you're new to something, you're unconsciously incompetent. You don't know what you don't know. And then through training and through discovery, you become consciously incompetent. You're aware of, oh, this is what I don't understand. And the training is obviously to make you consciously competent so that you understand exactly these terms and these topics and whatnot. And I think the goal ultimately, and this is where you get it from experience, is to become unconsciously competent, where it's just like riding a bike. It's just second nature. And that only comes with getting, as you say, time on the camera. The training is the best place to start, but then it's the experience that brings it all together.
I love that.
That's a great sequence. That's how you move to Jedi Knight, I guess.
Yes. That must be the fifth one, right?
Yeah.
You're a Jedi level.
That's where you don't even need a camera. You can just see the wall.
Yes. You feel it. Yeah.
I had a couple energy audits done on different houses I have, and I've lived in. One of my local friends here does blower door enhanced IR mapping. Can you talk about that?
So really, the blower door is the essential component of any thermal inspection of any building envelope. It is not a complete scan without one. You can look at a house with just an infrared camera and go through and get an idea of areas of missing insulation and find the big problems. What the blower door is going to do, though, is reveal all of those things and then some that aren't necessarily showing up under the natural stack effect. And that's the key there, is that you might show up to do an inspection with a camera on a day when it's calm. There's no wind outside. With a natural stack effect like that, there are areas of air leakage that you're not going to see. That's what the blower door does. It brings out those locations, especially on the lower floors. If you don't have that pressure differential, you can exacerbate those patterns by pulling air and depressurize the building. And it brings out all of these air leakage spots that you might not even think is a place where you might have air leakage. And suddenly it shows up. It happened to me. It was actually a weatherization training. I was in Rutland, Vermont. It was for the Vermont State Weatherization with Jeff Wilcox. And we did a walkthrough first with a camera, looked around, saw very typical what you'd expect for a building of that vintage and that construction. Turn on the blower door, and the interior walls start lighting up with cold air just pouring in from the attic space. Didn't see anything when it was calm, or before the blower door, before we depressurized. But you depressurize that building, and suddenly air leakage showing up in a spot now that you weren't expecting it. But again, that building on a windy day, it's going to be performing like that, and you would have missed it had you not run the blower door.
Yeah, there's a lot to this. I think we're giving people the idea. I also heard the term, and I think I learned it from Snell, is that when you decide to make an investment in thermal, allocate 20% at least for training.
Yeah, the training is the essential component of all of this. It's where I obviously learned what I know. It really is an eye-opener, and it allows you to start thinking in ways that you weren't previously, understanding things that you weren't understanding previously. Another quick example of this was a building in, I think it was in Middlebury, Vermont. It was this beautiful brand new construction, like a Frank Lloyd Wright design house, flat roof, open floor plan that we ended up at as part of a weatherization training. And brand new construction, 2x8 framing that they had put in 2-part foam. So it's all spray foam. I don't know the economics on this, but I think the ROI was decades. They were doing this to make this the most energy efficient building possible. And they had these 2x8 cavities completely filled with spray foam. And you would expect this building to be completely, just an example of perfection. They had missed an air sealing detail on the top plate. And when we put a blower door on this place, you could just see air, the effects of air cascading in across the ceiling. And mind you, they were at the point, they'd already finishing up the walls. I think they had the first coat of paint on, crown molding was up. We're beyond the roughing stage here. And I think the blower door pulled like 4,500 CFM or something that it just shouldn't have been anywhere close to. And it was a complete shocker because the fact that they had thought this spray foam would have been a much better performing building. And unfortunately it wasn't.
Yeah, spray foam's good in many instances, but if it's misapplied or not tested well, there's no QC done on it. Immediately after it's installed, it can miss a lot too. And that's just from personal experience. I love that allocate some for training. And I just wanted to go back to that real quick, Bill. I think that may have changed a little bit, that percentage that you threw out there.
Yeah, right. Because the cost of the image has come down.
The cost of these cameras has come down. I couldn't even put a number. It's come down a lot. We'll put it that way. I can pick up a camera today for less than a quarter of what I paid 15 years ago and have way more features on it.
And that's the challenge too, is that you're absolutely right. And I saw that 10 years ago. So actually going back to 2004, I think 2004, a company called Raytech had built the world's first sub $10,000 infrared camera. It was the TI-30. And I think it was a 120 by 120, a very low resolution, but it was under 10 grand. And people were just ecstatic because you can get on. Cameras were $50,000, $60,000 back then. There's no chance that a home inspector was going to be picking one of those up. And so that was revolutionary. But then that conversation started, well, it's less expensive. It's easier to use. Well, why do I still need training? Well, I go back to the hammer analogy. Again, I could give my younger daughter a hammer and she could pound nails into a board all day. You still want that. You don't want her framing the house. You want that skilled carpenter putting that building together. You want somebody who knows what they're doing. The hammer is cheap and easy to use. It's an inexpensive tool. But the price of the hammer has nothing to do with the skill set or the knowledge required to use it. And that's the same thing true with an infrared camera. I don't care how inexpensive your camera is. You still have to know how to use that tool properly.
Well, we see this in a lot of different tools. I'll throw out combustion analyzers as another great example. They give us a lot of data as technicians. But if you don't know what to do with that data and you don't know how to interpret what it's telling you, it's just a number on a piece of instrumentation. But yeah, thermal cameras are definitely the same thing. There's a ton of data coming out of that, but we've got to know how to interpret it.
As we wrap up here today, can you give some closing thoughts to our listeners on how they should approach thermography?
Going back to humility, approaching it with the perspective of being comfortable with knowing that you don't know everything. It's okay to say that I don't know. It's okay to ask questions. It's okay to learn and discover. And I think those things, it's embracing that education is really what's important, and having the courage to get training, to get the certification, to get out there and learn how to use these tools properly. It's only going to help you. It's going to pay dividends going forward to really understand how this technology really works. And I think to relate it to that, I think what I wanted to tie into this also is the role that mentoring plays in all of this and how important that is and how important it was to me. I'm only here today because of some amazing people over the 23 plus years that I've been doing this who have really played a role in my success and my professional development, especially when you're starting out. Having a great mentor, I think, is essential. I mentioned Jim Fritz, Rob Spring, John Snell, and John Keene, Gary Orlov. These are great mentors, but there are many others. I'm not going to get everybody's name, but just people that stood out in my career like Roy Huff, Harold Vandeven, Dave Sermons, Ron Lucier, Lowry Eads, even back to my time at Ski Vermont and doing skiing at Sugarbush. Molly Mahar was a woman I worked with, and Veronica Markle as well. Again, these are all people throughout my career that contributed positively to my professional development and really helped me along the way because they took the time to really help answer my questions. And so that's the other side of it. If you're getting into this, try to get a mentor, try to find somebody that you can really get that wisdom from, that perspective from, that can really help you and really help propel you forward in your career. I think that's one of the more important things that you can do.
Excellent. And Matt, you are carrying that legacy forward. So thank you for coming on, for speaking so openly, so graciously. And we will include some links in the show notes to some of the organizations you mentioned, including Blaze Infrared, which I think is very important for people to keep track of.
Well, thank you, Bill. And thank you, Eric. This has really been a privilege to be on. Thanks again for the invite. I really, really enjoyed this, and I hope we can do it again at some point.
Excellent. Thank you, sir.
Thanks, Matt.
Thanks for tuning into this episode of the Building HVAC Science podcast, where Matt Schwoegler joined us to talk about lessons in humility and heat transfer. I also host the Res Talk podcast, where you can learn more about the rapidly expanding world of home energy ratings and all those peripheral topics. If you have any questions or want to suggest a topic, reach out to us at marketing@truetechtools.com. That's TRUTECHTOOLS.com. And that's our website. And if you're interested in looking at any of the products we sell, test instruments, tools, etc., you can look at that website and use the offer code HVACBS for a nice discount. Thanks for listening to us and following us on the Building HVAC Science podcast. If you're not subscribed, please consider doing so. I want to thank you again for listening to this podcast, and until next time, take care.